Hello students, welcome to the class. We will continue the wave optics, and in wave optics I have discussed with you the wave front, and in wave front I have told you that what is wave front and what are the various types of wave front. A spherical wave front is there, for which we need point source of light. Cylindrical wave front is there, for which we need linear source of light, and finally plane wave front is there, which is the part of a spherical or cylindrical wave front. So in the wave optics, in the continued portion, this is your second lecture. So in this second lecture I would like to tell you that you should remember this thing is very important for your entrance examination, that for a spherical wave front, when we talk about the intensity, that intensity is proportional to 1 by radius of the wavefront square, and intensity is proportional to amplitude square. So amplitude of the wave is proportional to 1 by r. This thing you all should remember as an additional point which will help you in the entrance examination. And at the same time, for cylindrical wavefront, if we take the cylindrical wavefront, then intensity I is proportional to 1 by r. Intensity is proportional to 1 by r. Therefore, if we talk about the amplitude, A is proportional to 1 by r under root. That is the radius of the cylinders, coaxial cylinders, in which the wavefront is moving. And in case of plane wavefront, if we consider the plane wavefront, intensity does not depend upon the distance from the plane wavefront, and at the same time amplitude also does not depend upon the distance. That means it is free from the distance from the wavefront in case of plane. So this is the additional information that you are supposed to remember definitely, because it will be helpful to you in solving the objective questions, particularly asked in the entrance examination. After this, I would like to discuss with you the Hygens Principle. Hygens Principle, that is basically the concept of wavefront is there, and that wavefront concept, Hygens Principle, is basically the mechanism in which the light propagates in a medium. So we will, in the form of wavefront. So we will try to understand the Hygens Principle. Hygens Principle is basically based on the fact that light travels in the form of wavefront. If we talk about the wavefront, and if we consider that, here is the source of light, S, then you will observe that this travels in the form of wavefront. Here is the first wavefront. Now Hygens Principle suggests that every point in this wavefront behaves as a source of disturbance. So source of disturbance, which when it behaves, then it will be giving the, you see, in this way, in this way, in this way, and this is the new wavefront. So light from here, it has reached here again. So what I mean to say here, in this way you are observing that light is going in this direction, and this is basically the mechanism of light propagation, and ray is perpendicular to the wavefront. So this is the direction of ray is moving outward. That is the direction of flow of energy. Now we will try to understand the statement of Hygens Principle. We will see the statement of Hygens Principle. Hygens Principle is basically the assumptions that we have, that Heisen considered in order to explain the propagation of light. Here I would like to tell you that Hygens Principle is basically a method of geometrical construction as I told you, it gives the mechanism of light propagation in the medium. So it is a method of geometrical construction which gives the mechanism of light wave propagation in the medium, or light wave propagation. So it is basically the mechanism. It is basically the mechanism of light wave propagation. Mechanism of light wave propagation. How light propagates in the surrounding in the form of wavefront. It is based on few assumptions. Those assumptions are called as Hygens principle. What is the assumption? The first assumption is that every point on the given wavefront, the given wavefront is called your primary wavefront. The given wavefront which we will consider, the given wavefront is called primary wavefront. Every point on the given wavefront behaves as a fresh source of disturbance. Fresh source of disturbance means as a source. It is behaving like a source. And that source on the primary wavefront, I will show you the diagram also, in which it will explain that how it is the fresh source of disturbance. So it is, and that fresh source is behaving is called secondary wavelet. It is called secondary wavelet. So this secondary wavelet which moves in all direction with the speed of light in that medium. This is the first assumption that was of the Hygens principle. Hygens used to explain the phenomenon using this first assumption. Now we will talk about the second assumption. First you note it down, then I will move towards the second assumption. The second assumption of Hygens principle was that the tangential surface touching the secondary wavelet in forward direction, reverse flow of light energy is not possible. So in forward direction, called envelope of secondary wavelet gives the position of new wavefront. This is the way the light travels in the medium. This matter, what I have written in words, that will be more clearer to you if I will explain it with the help of diagram. So diagrammatical representation of wavefront, primary wavefront, secondary wavelet and the propagation mechanism will certainly help you in understanding the concept of Hygens principle in a better way. So let us try to move and try to understand the diagrammatic representation of this wavefront, this light Hygens principle. Try to understand the diagrammatic explanation of the Hygens principle. We are trying to explain the Hygens principle in a diagrammatic way. So first see it carefully that here is the source of light. This source of light is giving out the spherical wavefront. At any instant, AB is our primary wavefront. AB is our primary wavefront, that means given wavefront. You see, here it is written AB is the primary wavefront, that is given wavefront. According to Hygens suggested that every point on the given wavefront, every point that behaves as a fresh source of disturbance. And this fresh source of disturbance is known as your secondary wavelet. So what can we say? We can say that this is your secondary wavelet. Secondary wavelet. Every point on the given wavefront, which is the known wavefront, on the given wavefront, every point is behaving as a source of disturbance, fresh source of disturbance. That is it is behaving like a fresh source. When it is behaving like a fresh source, c is the speed of light in the medium. After time t, from here the light will reach here, from here the light will reach here, because it is the fresh source, it is behaving like a source, so it will emit the spherical wavefront. So in this situation, Hygens suggested that after time t, the wavefront will reach here. Ct is the radius, c is the speed of light, t is the time, so c into t, that will give you the radius. So wavefront, so light has reached here, light has reached here, light has here. Hygen suggested that the tangential surface, this is the tangential surface that is touching the secondary wavelet in forward direction. Touching the secondary wavelet in forward direction. Here also it is touching, but in forward direction, the tangential surface that is touching, this gives the wavefront A dash B dash. That means A dash B dash is your new wavefront after time t. Similarly, this will again behave as a source, every point will behave as source, and again we can create the wavefront, and this way the light propagates. So now the question arises, in this direction, here is also a surface that is touching these secondary wavelets from inside, reverse direction, A double dash B double dash. But A double dash B double dash is not the wavefront. Why? Reverse flow of energy, light energy, is not possible, and at the same time it is contrary to the experimental result. With experimental result it is not matching. So Hygen suggested that this is not the wavefront. This A double dash B double dash is not the wavefront, whereas AB is the given wavefront and A dash B dash is the wavefront, secondary wavefront after time t, and this fresh sources that are emitting the new spherical wavefront, these are called secondary wavelet. So this is the thing that you all should understand very carefully in order to understand the Hygens principle. But one more thing here, after a long distance, if you are considering a long distance, this curvature will go on decreasing, and when the curvature is nearly zero, it is the radius that becomes infinite, and then here it is the same thing, that is the plane wavefront. So in plane wavefront, here this is your plane wavefront, and every point on the given wavefront AB, again we can consider as the given wavefront, and when we can consider AB as the given wavefront, each point will behave as a source. When each point will behave as a source, then it will emit secondary wavelet in all direction. So after time t, the wave will reach here, the light will reach here, the light will reach here, and again if we take a tangential surface, naturally it will be a plane, because it is also plane, so it will be a plane, and then this is your new wavefront after time t. So here I have shown you with the help of a spherical wavefront, and here I have shown you with the help of plane wavefront. But this A double dash B double dash is not the wavefront, because reverse flow of light energy is not possible, and this is contrary to the experimental result. So whenever you are writing about the Hygens principle, the statement together with this diagram is essential, and the clarity of this concept will give you a better understanding to write the answer in a better way. So I hope that you have understood the Hygens principle. Now this Hygens principle, what you have understood, I will use the Hygens method to prove the law of reflection and law of refraction on the basis of Hygens principle. Law of reflection is what? Angle I is equals to angle R. This is the law of reflection, and sin I by sin R is mu, that is refractive index, is the law of refraction. These two law of reflection and law of refraction, we will prove using the Hygens principle just now, and it will be very important portion for your examination point of view. Here try to understand. I am trying to prove the law of reflection on the basis of Hygens principle. What is law of reflection? Law of reflection is angle I is equals to angle R. If we consider angle I is equals to angle R, that is the law of reflection, 1, 2 and 3, this is representing your incident wavefront. So how the wavefront is coming? It is coming in this way, and then it is going in this way. Wavefront is in this way, perpendicular to the plane of board. It is coming in this way, and then it is going in this way. So on wavefront, the ray is normal. So 1, 2, 3 represents the incident ray, and AB is representing the incident wavefront. 1 dash, 2 dash and 3 dash represent the reflected ray, and A dash, B dash is representing the reflected wavefront. So wavefront is coming in this way and in this way it is going. Now you try to understand, when the wavefront has reached here, this wavefront has reached here. So this distance is your c into t. In time t it has reached here, and in time t from here the wavefront has reached here. So this distance is also c into t, that is c is velocity of light into time, and this distance is also c into t. That means b a dash is equals to a b dash. So this distance is equal. This is angle of incidence, so this is angle of incidence. How it is angle of incidence? See, incident ray making with normal is angle of incidence, and this wavefront is making 90 minus I. This portion is basically representing the angle, that is, this portion is representing the angle that is 90 minus I, and this complete is 90, so this angle has become I. So this angle has become I. 90 minus I plus I is equals to 90, because between the normal and the surface the angle is 90, and between the wavefront and the ray the angle is 90. So this is I. So this wavefront making with the reflecting surface, that is also I, and here the wavefront making with the reflecting surface, that is also R. R represents angle of reflection, and xy represents the reflecting surface, and 1 dash, 2 dash, 3 dash represent your reflected ray. Now this is the basic mechanism. Only one thing you will have to keep in mind, that ray should be always perpendicular to wavefront. Ray should be always perpendicular to wavefront. Whenever you make the diagram, try to make the diagram in such a way that ray should always be perpendicular to wavefront. Now we have to prove the law of reflection on the basis of wave theory. Now this is the description of the diagram, that a reflecting surface is there, incident wavefront is there, AB, A dash, B dash is reflected wavefront. Now you see, I am considering the c is the speed of light. I am considering the triangle A, B, B dash and triangle A dash, B, B dash. In these two triangles you will find that B A dash is equals to A B dash is equals to C into T. This distance is same, because from here the wavefront has reached here, and in the same time the wavefront has reached here to here. So this distance and this distance should be equal, because the medium is same. So when you have understood this thing, then we can write angle B A B dash is equals to angle B A dash B dash is equals to 90 degree. At the same time B B dash is equals to B B dash, and this is your common. This is your common. So what we can observe by RHS? By RHS we can observe that triangle A B B dash is congruent to triangle A dash B B dash, and when the triangle is congruent, this angle should be equals to this angle. That means angle I is equals to angle R. This proves the law of reflection. Also, the incident ray, reflected ray and normal lie in the same plane. Why? Here it is perpendicular to the board. So basically we have to understand that I is equals to R, and the incident ray, reflected ray and normal all lie in the same plane. So this proves the law of reflection on the basis of wave theory of light. Some description that I am not giving in the support of words, that support of words to the This proof you can give by yourself, and then it will help you in better way of writing the answer, because your answer to the question should be supported by words. I have tried to make you understand the physics portion, and the auxiliary portion, helping portion of description, you can give by yourself, because I have made you understand everything in a very clear way. Now I would like to prove the law of refraction on the basis of wave theory. Here you see the diagram. There are two medium. One medium is 1 and other medium is 2. Here the speed of light is c, here the speed of light is v, here the refractive index is mu1, here the refractive index is mu2. So what we can observe, this is basically, we are considering the rarer medium. It is basically your 1, that is, it is air I am considering. It is not essential that it should be air, but I am considering that it is air. And its refractive index is mu. Mu2 not I am writing, I am saying that it is mu. So in this way, same, the incident ray is there. This ray should be normal. This ray should be normal to the wavefront. This is your incident wavefront. And this is your interface separating the two media. Medium 1 and medium 2 is separated by this interface. So what we can observe, 1, 2 and 3 represent the incident rays, and 1 dash, 2 dash, 3 dash represent the refracted rays. AB is representing the incident wavefront, and A dash, B dash is representing your refracted wavefront. I is the angle of incidence, and by the same logic here it is your I, and R is the angle of refraction, so here it is also your R, this wavefront. A dash, B dash is your refracted wavefront. So what I would like to tell you, that we have to prove the Snell's law of refraction. So C is the speed of light in medium 1 and B is the speed of light in medium 2. In the time light reached from A to A dash, covering a distance c into t, light is covering a distance of b to b dash in medium, so this distance is your v into t. Why? V is the speed of light in medium 2. Now if we want to understand it, I can say in triangle ABA dash, if I write sine I. Sine I is what? For this angle I, this is your 90 degree, this is your 90 degree. So for this angle I, this is your perpendicular and this is your hypotenuse. So perpendicular CT by hypotenuse BA dash. That is perpendicular by hypotenuse. This is here sine I. Now in triangle, if we see in triangle B dash A dash, this angle is R and this angle is 90 degree. So for R, this is your perpendicular. So sine R must be equals to perpendicular VT by hypotenuse B A dash. Take it as equation number 1 and take it as equation number 2. Therefore, if we consider that sine I by sine R, what we are getting? CT by BA dash divided by VT by BA dash, and this is giving you CT by BA dash into BA dash by VT. B dash will cancel, T will cancel, and you are getting C by V. And what is C by V? C by V is your basically the refractive index. C by V is the refractive index, that is mu. So in this way we have proved the Snell's law of refraction using the Hygens principle. So law of reflection and law of refraction can be easily proved using Hygens principle that we have seen. Again, I will request you the same thing, that the support of word to this concept you will have to give by yourself. It will develop your attitude of giving explanation, proper explanation to the diagram. You have understood that this is the interface, this is your A dash, C into T distance is there, C is the speed of light, T is the time, V is the speed of light in medium and is the time T. This time is same. Why? In the time light has reached from here to here, it has reached from here to here. So time remains the same. So this is the way we prove the law of refraction on the basis of Hygens principle. If the law of reflection or law of refraction is said, that prove it on the basis of Hygens principle or prove it on the basis of wave theory of light, meaning remains the same. So hope that you have understood this concept and it will be helpful to you. Have a nice day.